Hello and good evening to one and all. Now we are going to discuss about the 8085 microprocessors addressing mode. Myself, Mr. A. Balachandran, the Assistant Professor of VCE Department from the KSRCT, that is KS Rangaswamy College of Technology. Now we are entering into this topic, 8085 addressing mode. Addressing mode. The definition for addressing mode is the way of specifying the address is called as the addressing mode. That is, the way of specifying the address in the instruction is called as the addressing mode. It is also referred as the different ways that a microprocessor can access data are referred to as addressing modes. There are 5 types of addressing modes are available. These are immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and implied addressing mode. Now we are going to see these 5 addressing modes in detailed manner. First we are entering into the immediate addressing mode. That is, the immediate addressing mode means the data will be specified in the instruction itself. That is, the data may be 8-bit or 16-bit. This 8 or 16-bit data will be specified in the instruction itself, and also we can easily identify the instruction as an immediate addressing mode by seeing the letter I in the instruction. The examples of immediate addressing mode is the MVI space C, 25. 25 will be the hexadecimal number. In this, the 25 is the immediate data that is moved to the register C. Similarly, MVI space M, 7C, the data 7C will be immediately moved into the memory register. That is, M means the content of the HL register pair is the memory address. The memory address here is the 16-bit memory address. The data 7C is an 8-bit data. If suppose we have the HL register pair value will be, that is, the L register contains the 05 and the H register contains the 50, means its address will be 5005. It is a 16-bit address. The data 7C will be stored in the 5005. That is the meaning for the MVI space M, 7C. The next instruction LXI space D, 245E. Here the LX means X is denotes the it is a 16-bit instruction. Okay, that is 245E. 5E is the data that is stored in the DE register pair. That is, we have the some register pairs, that is register pairs, the different register pairs are BC, DE, HL or the register pairs. That is, X means 16-bit register. For the individual registers, it is an 8-bit register. That is, D is an 8-bit register, E is an 8-bit register. By combining the DE register, we can use it as a 16-bit register. That is, defaultly, if the D indicated in the instruction means, defaultly the another register will be E. That is, D's pair will be E. That is the 5E, that is 16-bit data 245E, that is separated into lower half and higher bit. Lower byte and higher byte, separate it as a lower byte and higher byte. The lower byte data will be stored in the register E and the higher byte data stored in the register D. That is, 5E will be stored in the E register, 24 will be stored in the D register. Okay, then next instruction ADI space 87, that is, the data, immediate data 87 will be added with the accumulator and the result will be stored in the accumulator A. Here the default register will be an accumulator A register. So that's all about the immediate addressing mode. That is, immediate addressing mode means the data will be specified in the instruction itself. Okay. Next is an register addressing mode. That is, which means the data transfer between register to register is called as the register addressing mode. So we have the different registers B, C, D, E, H, L and the accumulator. The data will be moved from the one register to another register is called as the register addressing mode. That is, the source and destination are both operand in an 8085 registers will be specified in the instruction. That is, for examples of the register addressing mode will be move a comma b. That is, the data stored in the register B will be moved to the register A. Okay. The next instruction, add space E. That is, here the default register one data will be in the accumulator, the another data will be in the register E. Here the addition operation will be done between the accumulator and register E. Then the result will be stored in the accumulator. The next is an SPHL, that is stack pointer and HL register pair. The data will be transferred between the HL register pair and stack pointer. The next instruction is an exchange instruction. Here the data will be exchanged between the HL register pair and the DE register pair. The next is an INR space L, that is the incrementing the value of the register L by 1. Okay, the 1 will be the default. If we want to increment the 2 means we have to write the 2 in continuous instructions, INR L. So that is register addressing mode, means data will be transferred from one register to another register, is called as the register addressing mode. The next addressing mode is in direct addressing mode. That is direct addressing. The 88, we know that 8085 microprocessor is an 8-bit data, 16-bit address. That is direct addressing mode, means the address will be directly specified in the instruction itself with the 16-bit address. That is, the examples of the direct addressing mode instructions will be LDA space 2000. That is, here the 2000 will be an address. The data available in the 2000 address will be moved to the accumulator or loaded to the accumulator. Okay. There is a small difference between the load and store instruction. Load instruction means the data will be moved from the memory address to register accumulator. Store instruction means the data will be moved from the accumulator to register. Similarly, the LHLD space 1111 means the 1111 will be saved in the HL register pair. Similarly, in 75, here the 75 is then data that will be 75 is an address, that is this is in and out instructions will be connected with the peripheral interfacing. Now when we are using the peripherals, that is interfacing the peripherals, we will use the in and out instructions. Okay. Next is an indirect addressing mode. That is the memory address where the operand located is specified by the contents of a register pair. That is, here the address does not specify in the direct manner, it is specified in the indirect manner. For example, take the move m comma d. Here the D register is a normal register, M is a memory register, that is HL register pair. So that is HL register pair, which means the content of the H register and L register will be the address. The value specified in the HL register pair will be the address. In that address, the data of the D register will be stored. Okay. Is it clear? Okay. For example, if we have the H50 in the H register, 00 in the L register, which means 5000 is the memory address. In that memory address, the data available in the D register is stored in that address. Okay. Same as the similarly MVI space M comma 55 is a indirect addressing mode. Similarly, we give the some more instructions of some more examples, that is ADC space M, that is addition with carry in the memory address. Then decrement the M register, that is decrementing the value of the HL register pair. Then push PSW, that is push the program status. These are the PSW has the some default addressing, that is the indirect addressing mode. Okay. Next we are entering into the implied addressing mode. The implied addressing mode means opcode specifies the address of the operands, that is it does not have any operands. that kind of instruction is called as an implied addressing mode. Okay, for example, CMA, which means complement the accumulator value, there is no need of the any operand. Similarly, STC, that is set clear, set carry will be setted as a 1. Then REL, rotate accumulator left. Then DAA means double addition of the accumulator. This instruction does not have any operand, so these are the instructions coming under the type of implied addressing mode. Okay, it's clear. Okay. And next is just a small example. Machine control group EIDINOP halt sim rim. That is, EI means enable interrupt, DI means disable interrupt, NOP means no operation, HLT means halt. Then these instructions will be a null addressing mode. These also does not have the, these are does not coming under any of the addressing modes. Okay, similarly set instruction, sim under rim, these are coming under the type of null addressing mode because it does not coming under any of the addressing modes which we discussed in the earlier. I hope this class will be very useful. If any doubt, please share your comments or any rectification in my class or any doubt in this lecture. Please share your comments in the comment box. Thank you.